jumping through the historical background, electric charge is on its tiniest level, contained with some of the basic building blocks of, at least the material universe. Protons that have a positive charge are fixed in place. They're relatively massive compared to electrons, like about more than 1,800 times more massive than electrons, so they're fixed in place inside material. If I were to say move some protons, I'd basically be moving full atoms out. So we're going to treat the protons as being pretty much fixed inside the nuclei of atoms, but electrons with negative charge are more movable. Now, I can define materials in the most general sense in terms of conductors versus insulators, where a conductor in a conductor electrons can move. Not all electrons, but it's made up of some type of material such that at least there's some movement of electrons, so therefore electric charge can move freely. Most metals are conductors. And in fact, I believe the one definition of metal is hey, anything that works as a conductor. Anything that doesn't work as a conductor, where the electrons are not free to move, is classified as an insulator. And an insulator doesn't mean it blocks the effect of electric charge. It simply means that electric charge cannot move. Now, if I have, let's look at conductors for just a moment. Suppose I have a solid conductor. And inside that solid conductor, I cause to exist two identical charges, positive or negative. And everything else is largely neutral. That means that this positive charge looks around at the universe to anthropomorphize the heck out of this thing, and just sees this other charge. So, two like charges will exert repulsive forces on each other. And whatever else I can say about those force particles is those forces, since the force is always going to be repulsive. I mean, it gets smaller as we get farther away. The force is a constant times the charge of thing 1 times the charge of thing 2, divided by the distance between them squared. So as the distance gets greater, the force gets smaller, radially outward, one from the other. So they're going to get as far away as they can. Now, if I were to start then with, instead of 2 pieces of charge, a bunch of pieces of charge, all of the same type, then they're going to try and get as far away from each other as they can. And the best that they're going to be able to do, given a little bit of time to spread out, is to smear themselves around the outer edge of that conductor. So, extra charge on a conductor builds up on the outer surface. Now that's an important note. Suppose in here I've got an empty bubble, a free space. A charge is not going to move within that bubble because it's not as far away as it can possibly get from everything else, and that's the overriding concern here. So there will be charge, if there's excess charge on this conductor, that will be on the outside edge and nowhere else. Now, suppose that I have a conductor. And I bring something else over. A wand, we'll see when we look at electric fields, and I'm using an object that has a sharp point on it because that makes the electric field stand out more strongly. We've got a wand that, say I bring that near a conductor. Now, I've got negative charge here. So it's going to be exerting, this object, I'm not saying, oh, there's no charge on it whatsoever. I'm saying the net charge is 0. You have positively charged protons and an equal number of negatively charged electrons. So what's going to happen is that the electrons here are going to feel a repulsive force. So they're going to end up as far away as they can from this and from each other, so they're going to kind of spread out on this side. What this means is that there are holes left over here where the electrons were pushed out of. So I'm going to get some positive charge over here. Here is charge negative Q. I'll get charge positive Q here, and get charge negative Q over that area. Bearing in mind still that the total charge is equal to 0. Now there is a way to cheat, so to speak, and end up getting rid of some of this charge. Suppose on this side I had a wire. Then, step 1. Bring charged object close. Step 2. Like charge is repelled. If this is a negative charge, it's going to push electrons out, and then what's going to happen is that charge moves up or down wire to balance. Now in this case, this negative charge sees, again, yes, anthropomorphizing this to a ridiculous extent, it sees a way to escape, a way to get farther away. So the negative charge escapes down this wire. Now if I brought a positive charge in, or I move this negative charge out, then I need more negative charge up here, So negative charge will be pulled up the wire from the rest of the universe. But suppose I take this then and go to step 4. And cut the wire, then step 5 is remove the charge. So now I'm removing the charge. This effect would go away, but the electron, either I've got, like this case, where the electrons went away and now they've got no way to get back, or I pulled extra electrons up and now they've got nowhere to go. The next step then is I've got extra charge now, and that'll build up on the outer surface, trying to get as far away from each other as it possibly can.